Hi students, today we will discuss about hydrocarbons. Hydrocarbons. So what is hydrocarbons? Hydrocarbons means hydrogen compounds which are formed by hydrogen and carbon or carbon and hydrogen only present in a compounds. That compounds we will call hydrocarbons. If other than carbon is there, means that we will call heterocyclic compounds or hetero compounds, like we will call. So it is hydrocarbons. It is classified as two types, that is saturated hydrocarbons and unsaturated hydrocarbons. Saturated, unsaturated, and next one more is there, that is cyclic compounds. Compounds are cyclic. So like it is also called as arenes, aromatic compounds. Example in this chapter we will discuss about this 1 and 2 and 3. So cyclic compounds, example benzene. So these three about fully we will discuss in this chapter. Okay, before chapter already you know saturated hydrocarbons means that is alkanes. Unsaturated hydrocarbons means it is classified into two types, that is unsaturated hydrocarbons, two, that is one is alkenes, second one is alkynes. So about this you know already very well in this before chapter. So even also we will discuss few points about alkanes. So alkanes example, formula CnH2n plus 2. Alkenes general formula CnH2n minus H2n. Okay, this is CnH2n minus 2. So this is the saturated and unsaturated. So saturated means what? Single bond present in carbon and carbon between, or single bond present in carbon. So that is we will call alkanes, saturated. Unsaturated means carbon and carbon between, carbon between double bond present. So that is alkanes. This one alkyne, carbon and carbon between triple bond present. So this is hydrocarbon. This one we will call multiple bonds, also known as unsaturated hydrocarbons. Saturated means single bond present in the carbon atoms, one carbon atom and one more carbon atom. So in this about alkanes we will discuss. Before this, what is this? Before alkanes we want to discuss about alkanes. Before that we will discuss about some basic knowledge about hydrocarbons. So hydrocarbons is the source of energy. It is a source of energy like LPG, CNG and LNG. What is this? LPG means liquefied petroleum, liquefied petroleum gas, this is compressed natural gas, this is liquefied natural gas. So this is a source of these all obtained from where? Earth crust, obtained from earth crust, fractional distillation, obtained from fractional distillation process. LPG and CNG obtained from earth crust. We have to refine means we can withdraw that, we can separate with the help of fractional distillation process. Next, coal is obtained by the destructive distillation. Distillation process. Destructive distillation we are getting coal, fractional distillation we are getting this and all LPG and CNG, petrol, diesel, kerosene, all things. So these all are where it is, all are hydrocarbon, mixture of hydrocarbons only present in this, all the components, all the compounds, all organic compounds. Petroleum, LPG and kerosene both are, this is less pollution, it is produces less pollution. This is somewhat more pollution, but both are using domestic fuel. Kerosene and LPG used for domestic fuels. Okay. Next, we are discussing about petrol and CNG is less polluting. Petrol and CNG less polluting agents. Okay, CNG and LPG are less polluting agents. Okay, so this is about basic knowledge about hydrocarbons. So hydrocarbons we are using everyday daily life. Some dyes, colors preparing industries and polymers, you know, polymers, polythene, polystyrene, polypropylene, like polymers also we are using these hydrocarbons only. So petrol, diesel, kerosene, all paraffin wax, diesel and coal, coke, all are carbon compounds only. So dyes also carbon compounds, polymers also carbon compounds. So this is the main energy source. Okay, now we will discuss about what classification, that is alkanes. Alkanes. So here classification hydrocarbons are different types of, depending upon the type of bond present in the carbon. So single bond present means that is alkane, double bond present means that is alkene, and triple bond is there means that is alkyne. In this chapter we have to discuss about all these three and aromatic compounds also, preparation methods, structure, general properties and structure of these alkanes, nomenclature of alkanes, how can you write a name, Next, structure how it is there, that and all we will discuss. Chemical properties as well as physical properties and preparation methods also we have to discuss about fully alkanes. So now first of all, alkanes are open chain. Alkanes are open chain compounds. Okay, open chain compounds only. No, general formula CnH2n plus 2. CnH2n plus 2 general formula. So first member of alkane is methane. Okay, first member of alkane is methane. By substituting hydrogen atom, methane formula is CH4. By removal of one hydrogen, substitute the one hydrogen atom with the help of CH3, we will get substitution reaction. We will get what? CH3 and one more CH3. That means here CH4 is there, no? 4 hydrogen atoms is there. In this, removal of one hydrogen, addition of one CH3, we will get CH3, like this CH3, and this CH3 attach here CH3, like so. From ethene, this is ethane, comes from where? Methane. Yes, no? Methane. Ethane comes from methane by removal of one hydrogen by substitution of CH3 group. Okay, ma. So this methane comes from where? It is obtained from marsh area, or that was only marsh gas we will call, that is, and coal mines also it is available. If you replace one hydrogen atom, we will get next member of that is homologous series, next member of this one. Again here we can replace one more hydrogen with CH3, one more hydrogen. What will come? CH3, CH2. Here one hydrogen we can remove, no, CH2 will come. This CH3 attach this side. This is methane, ethane. This is what now? Propane. Here also again we can remove one hydrogen from here. We are adding CH3 group, then CH3, CH2, again CH2, this one CH2, and this CH3 attached to here CH3. This is butane. Okay, this is ethane, this is methane. Methane, ethane, propane, butane. So like removal of one hydrogen or replacement of one hydrogen, we will get next member of these compounds. Okay, this is join the next carbon. Required amount of hydrogens will be attached to carbon. So required amount of hydrogen we need to add to next carbon. This compound added to here. How much required amount of hydrogen this carbon want? That hydrogen also having that carbon atom. Okay, this is. So next we will, these hydrocarbons are inert. Yes, no? These hydrocarbons inert only, no? Inert means what? It is methane. These hydrocarbons are inert. Why inert? All are single bonds is there, means it is sufficient bonds is there. Even also it is all sigma bonds, so that only it is inert. But special conditions it will be react with other. It cannot react simply. It cannot react with acids, bases. Cannot react with acid, bases, and reagents, organic reagents. It cannot react with acids, bases, as well as some organic reagents. So that only we will call this is paraffins. Paraffins. Param means little, small. Affins, Latin name, affins, affinity, little affinity, that means less reactive. Okay, this is a less reactive compared to alkene and alkyne. This is a less reactive. Okay, next, structure of you can take a screenshot, then you can write. Okay, structure of alkene. Structure, how it is there. So first remember CH4. Structure of this one, carbon atomic number 6. Carbon atomic number 6. So electronic configuration 1s2, 2s2, 2p2. So valency shell is second shell. Second shell having here 2 electrons, here also 2 electrons, here also 2 electrons. So here 4 hydrogen atoms attached to carbon, but here availability of single bonds, how many, single electrons, how many is there? Only 2 electrons is there. 2 electrons participated with bonding 2 hydrogen only, no, but 4 hydrogen is there. How? Excited state, this is ground state, excited state, what will happen? This 1 electron jumps to here, 1 electron jumps to here, then already 2 is there, this electron comes to here, here we will get 3. Total how many is there? 1 s orbital, 3 p orbitals is there. So this 1 s orbital and 3 p orbitals intermixing to form sp3 hybridization. Involved in hybridization. So sp3 hybridization, it is involved means 1 2 3 4 orbitals we are getting. 4, this is carbon, that 4 orbitals I want to write like how I want to write like this 1 orbital, and this is 1, this is 1, this is 1. Okay, that 4 orbitals having 4 single electrons, no, that 4, this is carbon atom, this is 1 hydrogen, CH4, no, this is 1 hydrogen, that hydrogen atom also 1 electron, opposite spin, we should write oppositely. Here also 1 hydrogen, we should write opposite direction, that. So this one and this one, and this one, like this. So this structure, what now? Structure is tetrahedral structure. Tetrahedral structure. Bond angle is 109 degrees, 109.5 degrees bond angle, in where CH and that means HCH bond angle, HCH bond angle, like this is there. Okay, 109 degrees tetrahedral shape. Okay, next 4 hydrogen atoms lie on the corner of the tetrahedron, regular tetrahedron. Next, bond length of CC is 154 pm. If one more C is there means CH3. So bond length, this bond length 154 picometers. Hydrogen and carbon bond length, like here hydrogen is there means this bond length is hydrogen and carbon bond length 112 picometers, 112 picometers for hydrogen and carbon. Carbon bond length is 154 picometers. Okay, this is about structure. Next, all bonds, what type of bonds is there? All are sigma bonds here. Sigma means we can represent like sigma bonds. How many sigma bonds? 4 sigma bonds. 4 sigma bonds present in this CH4 molecule. Tetrahedral shape. Bond angle is 109 degrees, 109.5 degrees. HCH bond angle, that is. Next, bond length is, if carbon if it is attached to one more carbon, this much is there. If hydrogen carbon means 112 picometers. So it is head-on overlapping only, no? This is head-on overlapping. Head-on overlapping. Overlapping present in this compound is head-on overlapping. Head-on overlapping. Overlapping means this p orbital and s orbital, this is overlapping. It will form sigma bond. So this overlapping we will call head-on overlapping. Okay, this is about structure. Next, nomenclature. Nomenclature. So nomenclature means name. First member of this one, CH4. So this is methane, you know very well. This is a IUPAC name. If C2H, how much CH2 we should add? H6 is ethane. Okay, C3H8 we will call propane. C4H9 butane. C5H, sorry, H9 not here, H10, here H12 is pentane. 5 carbons, no? Pentane. C6H14, here nomenclature and as well as isomerism also we will take both at a time. Isomerism. Okay, nomenclature and isomerism, both I will explain at a time. And isomerism, C6H14 hexane, right? Up to 10 we will discuss. C7H16, what is that? Heptane. Okay, C8H18 octane. Nomenclature, octane. Some compounds also we will write. C9, here I will write C9H20 nonane. C10H22 decane. So this is the alkane nomenclature. Here isomerism, we have one formula about isomerism. I will explain. See, this one have isomers. How many possible isomerism means nomenclature. Now we know nomenclature means one carbon atom is there, all single bonds, ANE. One carbon means meth, 2 carbons eth, ANA. All ANE will come, all are same single bonds only. The general formula of that is nomenclature. CnH2n plus 2, no? You can apply this formula. You can take 5 carbons, 5 2 is 10 plus 2, 12 will come. If you can apply here 6 carbons and 6 into 2, 12 plus 2, 14 will come. This is the formula for all the compounds we are writing. Now isomerism means what? Definition. Isomerism means same molecular formula, but different arrangement of atoms is known as isomerism. Okay, same molecular formula but different arrangement of atoms in a compound is known as isomerism. That is definition. Now CH4 have, we want to write CH4, how many possibilities is there? Like this only, no? CH4 like this only we will write. One more structure will come, no, this is only. But this one have CC H, same molecular formula but different arrangement of atoms. This is only we should arrange. We want to write anything in these 2 carbons, no, we can't write anything. But C3 having also we can't write any compound, any position. Same we want to write like this only, all 3. So no isomers 1, 2, 3 carbons. But butane have two different. How we will write? See, 1, 2, 3, 4 carbons. N butane. This is N butane having same molecular formula, no? Structural formula I want to write how many possibilities. This is one structure. From this second structure also 1, 2, 3, 4. Correct only, no? So one hydrogen here one hydrogen, one here one hydrogen here one. See, 6 hydrogens, this 2 and 9, this is 10. Here 10 is there, no? 4 carbons, 1, 2, 3, 4 carbons. So I want to represent 1 carbon, 2 carbon, 3, 4 carbons. Okay, here also 1 carbon, 2, 3, 4 carbons. So 4 carbons, different arrangement is there, see, but hydrogen same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same number of, same molecular formula, different arrangement of atoms is known as isomerism. Okay, this is isomerism. For isomerism we have one formula. This one having how many isomers? I will tell this one having 3 types of isomers. How I will tell? No, I have one formula, that is 2n minus 1. 2n minus 1 means this one butane having 2, that n is 2. 2 2s are 4 minus 1 3. Next this one having how many? 3, no? Before 1 3. So 2 into 3, 6 minus 1 5. Hexane having 5 isomers, structural isomers. Structure different is there, structural isomer. So that is functional isomer and positional isomer, functional group isomer, or metamer, tautomers, that and all no need in this chapter. This is enough. Structural 5 came. Next this one how much? 5 into 2. For writing this one 7 and 16, C7 and 16. Heptane have how many? I want to take 5 here instead of n, this 5. Before isomers only n is equal to before isomers n equal to before isomers how much? For I want to write this one, 5 is there. 5 2s are 10 minus 1 9. For this one it is not applicable, amma. You should remember 18 only will come. That 18 is hydrogen how many? That only you should write. 18 isomers. Next this one, 9th one, 9 compound. 18 you can take. 18 into 2, 36 minus 1 35. This is having 35 structural isomers. Next one is 75. No formula apply. This is also we should remember. This one and this one is we should remember. Remaining we can apply this formula. Okay, ma? Okay, you can take screenshot, note it down. Okay. Note it down. Next, nomenclature. We will nomenclature. I will take one example, then I will explain. Okay, ma. Okay. Now, nomenclature based upon the number of carbon atom attached to the carbon atom. That also we want. Okay, ma. Based on number of carbon atoms attached to carbon attached to carbon to a carbon atom. The carbon atoms is termed as attached to a carbon atom. The carbon atoms termed as primary, secondary, tertiary, quaternary, like we will call. Example CH3 is there. Here this one is primary carbon atom. This one also primary, because this carbon atom attached to only one carbon atom. That's why we will call primary carbon. Okay. Next, CH3 CH2 CH3 is there. Here this is secondary carbon. This is also secondary carbon. This carbon attached to two carbons. That's why this is secondary carbon atom. This carbon also attached to two carbons. This is also secondary carbon atom. But this is primary. This is also primary. This is attached to only one carbon, not this and all. This carbon also attached to one. That's why primary. Next, tertiary means what? CH3 here H. This is tertiary carbon. What is tertiary carbon? This carbon attached three carbon atoms. That's why we will write this is tertiary, and that means we can represent like this, 3 above like degrees, tertiary carbon atom. Now quaternary carbon means 4 carbon atoms attached to the one carbon atom. That is we will call quaternary carbon. That is this one. Quaternary carbon. This is quaternary carbon. Which one? This one. Remaining all tertiary carbon only. This one attached one carbon. This one also attached this carbon. This one also attached this carbon. This one also attached this carbon. This is also known as neopentane. Nomenclature. Common name neopentane. IUPAC name 2,2 dimethyl. Why di? Di means 2 methyls. So numbering where you give, sir, 1, 2, 3, right? 1, 2, 3. Second carbon having 2 methyl groups. 2,2 dimethyl propane. IUPAC name. Okay, ma. Okay, note it down. Next, I'm taking one. Some iso, neo, like is there? No, that also we will take one example. CH3, CH2, CH3, something is there. This one we will call iso. 1, 2, 3 carbons means what? Propane, no? Isopropane. Isopropane. Isopropane means here alcohol something is there means isopropyl alcohol, like we will give name. Okay, iso group means like this, otherwise we will write like this, isobutane. Butane means 4 carbons. Iso means 1 carbon down is there, isobutane. Next, isobutane. Neopentane, isobutane. Okay, this is it. Next, I will take one example. Only one compound we will write how many names for nomenclature. In our textbook also given, I think 6 carbons, 5 carbons, CH3, CH2, 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 1, 2, 3, 4, 5 carbon. Here alcohol. Next, second one, name what? Next, CH3, CH2, 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 4. Here one CH3. Okay. Here alcohol. Next, third one, CH3, CH2. Here OH, CH2, CH3, sorry, CH2, 1, 2, 3, 4, CH3. This is one type of compound. Name what? Next, fourth one, CH3, CH2, CHOH, CH2, CH3. Name. 4 completed. Fifth one, I want to write here. Fifth, CH3, CH2, 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 1, 2, 3, 4, 5. So for writing that, one CH3, already wrote one CH3 beside carbon. Here CH3 is there. Here CH, 1, 2, 3, 4. Okay, CH2 OH. This name. Next, sixth one. Same alcohol and CH3, CH, OH, CH3. So alcohol and methyl group also same compound. 5 CH3. Sixth. Seventh one, I want to write here. Seventh one, CH3, C, CH3, CH3, 4, CH2, OH. 5 carbons, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that one. Next, 8th one, CH3, middle carbon, second carbon. Here one OH, here CH3. Okay, this is a types, only one structure. It is having 8 different compounds I wrote now. Okay, if we will write OH this side, one more will come. No, not amma. That name also same name will come. CH3 will come here, OH will come here, name same will come. Next, sir, this CH2 we can write this side, no, name same will come. Sir, this CH3 here, OH also here, no, name again same, because this is second carbon, this is also second carbon. This 2 we can write here, same name will come. This is possibilities. So now names of this compound, names I will write this side. See this one, 5 carbons, no, pentane, pentanol 1, pentanol 1 or 1 pent 1 all also we should write. This is the name of first one. Second one, 1, 2, 3, 4 methyl, 4 methyl. Why 4 methyl? Functional group is there. 1, 2, 3, 4. Sorry, 3 methyl. 3 methyl. Okay, 3 methyl. 3 methyl. Third position methyl group is there. That's why 3 methyl. Total carbons 1, 2, 3, 4. 4 means butane. Okay, butane. Butanol 1. Butanol 1 butanol otherwise. Next this name 1, 2, 3, 4, 5. 5 means penta. Penta 2 all. Pent 2 all. Okay, ma. This name 1, 2, 3, 1, 2, 3. Same 1, 2, 3, 1, 2, 3. Third carbon having alcohol. So pent 3 all. Next this one, fifth one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 means pent, correct. Second, 2 methyl. Pent 1 all. Next this one. 1, 2, 3, 4. But 4 means but 2 methyl but 2 methyl but 2 all. Butanol 2 also. Butanol 2 also we should write. No problem. This is now this is 1, 2, 3. 2, 2 dimethyl, because second position have 2 methyl groups. 2, 2 dimethyl. 3 chain, no, 3 means propanol 1 propanol or propanol 1. This one 1, 2, 3, 4. 3 methyl, because 1, 2, 3 no, third position methane is there. 3 methyl, fourth no, total butanol 2 or 2 butanol. See, these all have different names. So this is to try to understand nomenclature, compounds nomenclature. For that only I am taking this example. Down space is there, but I didn't see, so that only I wrote there. Okay, next this is about fully examples of nomenclature. Okay, next in this nomenclatures, already you know nomenclature means why we will write here 1, because here functional group is there. Functional group carbon we want to give first preference, number lowest number, so I give lowest number. Next this is a second one, it is a substituent. That's why this side we are giving. Here 1, 2, 3 third position, this side we will give numbering, mean third position functional group, so that only this side we are giving second position only functional group is there. Here functional group here, that's why 1 carbon we should give that one. Okay, second carbon have 2 substituents. Next functional group here is there. Here onwards we will give means 1, 2 third position functional group will get. That side means second position. That's why that side I am given. Okay, that and all IUPAC rules already before chapter you learned. Okay, next, preparation of alkanes. How to prepare alkanes? Preparation of alkanes. Okay, preparation of alkanes. How can you prepare? From first one, from unsaturated hydrocarbons are alkenes and alkynes. We want what, amma? We want alkanes. Where we are getting? From alkenes and alkynes. How we will get? See, how we will get alkanes and alkenes in the presence of, this is also known as amma hydrogenation. Hydrogenation means what? No, hydrogen's addition of hydrogen in the presence of palladium or nickel or what is that, amma? Palladium, nickel and platinum and PD, palladium, these two, in the presence of these two catalysts, at room temperature also, at room temperature also we can prepare, but nickel catalyst not possible, amma. At room temperature we want a high temperature and high pressure. High temperature and pressure required for nickel catalyst we are taking. PD and PT means platinum and palladium. At room temperature also we can prepare these compounds. Okay, ma? Okay. Example, CH3 C triple bond CH plus hydrogen we should add. So simply, chemical reactions, preparation methods very easy. So see, here two hydrogens attached. Here how many hydrogens we want? 1, 2 hydrogens. Here 1, 2 hydrogens. 4 want. So 2 moles of H2 gas you can take. In the presence of PT and PD, we will get CH3 CH2 CH3. Okay, ma, this is propane. So all single bonds, no, this is only alkane. Preparation of alkanes, we are getting alkane from where? Propane. YNE. From propane we are getting propene. Next one, one more example. CH2 double bond CH2. This is ethene, ENE plus H2 we will get in the presence of PT and PD, palladium. So here what is the role of PT and PD? To activate the hydrogen HH bond. To activate HH bond, that bond will be cleavage. So then these hydrogens attached to the carbon atoms. So that only we are using this two. Next, CH3 single bond CH3 we are getting. This name is ethane. Alkane we are getting, alkane. So this is about this one. Next, one more, CH3. All are same only, amma. This is example. First one, preparation of alkanes. Next, this is also known as hydrogenation. Hydrogens adding. That's why hydrogenation or reduction also we will call. Addition of hydrogen, reduction only, no. Reduction also we will call. Next, from alkyl halides. Second one. From alkyl halides. Alkyl halide means this is alkyl group, X is halide. From alkyl halides except fluorine, alkyl halides from from except F alkyl halides from except F on reduction with Zn on reduction with zinc metal reduction with zinc and hydrochloric acid, zinc and hydrochloric acid, alkyl halide except fluorine on reduction with zinc and hydrochloric acid, we are getting alkanes. Simple alkanes. Okay. See, alkyl halide CH3Cl is alkyl halide plus in the presence of Zn H plus addition of hydrogen only, this is also. Now we are getting CH4 methane plus HCl. Where HCl? Here 2 hydrogens is there with 1 hydrogen HCl. Next hydrogen attached to here HCl in the presence of zinc and hydrochloric acid. Next one more C2H5 and Cl plus H2 gives less to Zn and H plus CH3 plus 2H HCl. One HCl, here C5 is there, here H6 is there, here is 6, 1 hydrogen attached here, CH3 ethane we are getting, this is methane. So this is the second one from alkyl halides. Next one is there, amma, in this second one is there. What is that? That reaction we will call Wurtz reaction, WE. So I will explain from here. From alkyl halides, second one in this alkyl halides on treating with alkyl halides on treating with sodium only, no, Wurtz reaction, sodium, yes, treating with sodium in the presence of dry ether, we will get alkanes. So that one, see, CH3Cl or bromine plus Na 2Na plus Br, again here CH3. See, in this sodium metal dry ether, see, we are getting CH3. So even number of alkanes, even number of carbon alkanes only we are getting. This is ethane plus NaBr. Which NaBr? 2NaBr. Why here 2NaBr is there? We can remove this NaBr. This reaction we will call Wurtz reaction. This reaction we will call Wurtz reaction. WERTZ. Wurtz reaction. Okay. Even number of carbon atoms only will involved in these reactions. Next, from carboxylic acids. From carboxylic acids. from carboxylic acids. Third preparation method, from carboxylic acids. From carboxylic acids, also known as decarboxylation. That means CO2 gas we can remove from here. So in this also two types is there from carboxylic acids. That is what is that? Carboxylic acid and reacts with carboxylic acids and reacting with soda lime in the presence of reacting with soda lime to form one carbon less alkanes. This is important. One carbon less alkanes we are getting. That means example C, CH3 COO Na, COO minus and Na plus. Here we will take NaOH and CaO. This is only soda lime, the mixture of soda lime means what? Mixture of sodium hydroxide and calcium oxide, that is soda lime. Now see, here we are getting CH4 only plus Na2CO3 CM CO2 and O, CO3, Na and Na, 2Na, Na2CO3, this hydrogen attached here, CH4. This is one reaction. Same in the second one is there, that is coal base electrolysis. Coal base electrolysis. Same reaction. Coal base also did this on heating with soda lime, carboxylic acid on reacting with soda lime. Soda lime means mixture of sodium hydroxide and calcium oxide to form one carbon less alkanes. One carbon less, no, here 2 carbons is there, here only 1 carbon less alkanes we are getting. Okay, next we will take coal base electrolysis, aqueous solution of sodium and potassium salt. Aqueous solution of sodium and potassium salt. Aqueous solution of sodium and potassium or sodium and potassium salt of fatty acids. That only carboxylic acid means fatty acids. At anode, an electrolysis at anode we will get alkanes. So that example also I will write. See, 2CH3 COO minus Na plus on electrolysis, no, water electrolysis, presence of electrolysis. Now we are getting some simple fragments. Electrolysis is alkane and containing even number of carbon atoms, that is CH3 at anode, and then CO2 plus H2 plus NaOH, sodium hydroxide also 2 moles, because here all are 2 moles, no, 2 moles. CO2 also 2 CO2. Okay, so this is the products. See, even number of alkane, CO2 gas, H2 gas, and NaOH also produced. Okay, about this one, three preparation methods completed. In this electrolysis, about I will explain at anode, at cathode what happened. At anode, same CH3, 2CH3 COO minus Na plus is there, no, that one gives rise to what happened, CH3 COO minus plus Na plus, it will be dissociate 2 Na plus 2 no, here also 2, here also 2, it will be dissociate at anode. Then second step, not at anode, it is a overall reaction, general reaction at a anode. Now first one, this CH3 C double bond O minus is there, no, that minus will changes into 1 2 3 4 5 6 electrons, no, total 6 electrons for what is that, oxygen having 6 electrons. So that minus 1 O minus, that means loss of 2 electrons, here 2 minus charges is there, loss of 2 electrons, we will get CH3 C double bond O 1 2 3 4 5, one radical we are getting, radical. Okay, so the cleavage of this one, next see, cleavage of this bond, CH3 radical plus CO2 gas. See, like this it will be dissociated at the anode. Okay, that is overall reaction. 2 CO2 on this 2 only, no, here also 2 is there, here also 2 is there, CH3 2 CH3 radicals, here also 2 is there. Okay, now this 2 CH3 radicals, this one we will call acetate radical, that's 2 CH3 one radical, 2 CH3 radicals, we will write like plus, no, 2 CH3, same both are. Now we will get CH3 and CH. This is only this one number. So this much mechanism is there at anode. 2 CH3 COO minus, that means 2 minus charges, because here loss of Na plus, no, loss of 2 electrons, electrons extra is there for this one, loss of 2 electrons, we will get like this compound. It is having valence electron 6, no, 6, one is forms bond, remaining 5 we will represent like this. So it will break this one CO2 like, and this one have less number of hydrogens is there, that means CH4, no, methane means here CH3 only is there, that's why radical, that radical 2's combined we will get this compound. This is at anode. Now at cathode what, at cathode H2O is there, H2O, that H2O dissociated into OH minus plus H plus. Now H plus H2 gas will be formed. H plus not, OH minus H radical we can represent. So now 2 H radicals combined, H2 gas, that is at cathode. Where at cathode. At cathode H2 gas, at anode methane, sorry ethane gas or ethane. This is the about alkanes preparation. This is only. Next, physical properties we will discuss. Physical properties. What is physical properties? Physical properties. Physical properties. First one, carbon 1 to carbon 4 is gases. Carbon 5 to carbon 8, carbon 17 is liquids, liquid state, and then carbons 18 onwards solids. So liquid, gases, liquid, solid, all state of hydrocarbons like this is there based on the carbon number. Now solubility how? Solubility decreases in water, decreases with increase carbon number. Okay, next, solubility of boiling point and the melting point. So carbon number increases, boiling point increases because gas is no less boiling point than liquids is less than solid, boiling point increases. Next what? Boiling point, melting points, and solid, liquid, gas over. Next, boiling point, one difference is there. N-butane, 5 carbons, 4 carbon, N-butane and isobutane is there, no? This one boiling point more than this one, isobutane. N-butane boiling point more than isobutane. That means branches increases, boiling point decreases. Okay, branches increases, boiling point decreases. Okay, about chemical properties tomorrow we will discuss about chemical properties. Okay ma'am, thank you.